Hello everyone. This time around we're going to be discussing JavaScript objects. To lead into this, we have of course been discussing data types one way or another, this way or that way. Pretty much everything we've done up to this point has really come down to data types. Some of the data types we've of course discussed previously are things like string, number, and Boolean. And I think that I mentioned to you in a previous cast that those types of data types are often referred to as being scalar data types. But with the last episode on functions, we also got started now talking about complex data types. Functions are of course a complex data type. If you compare functions to the scalar types are of course very simple, where they just simply store a value. A string is just a string, a number is just a number. But we saw that a function is certainly a bit more interesting than that, since a function contains potentially many executable statements. So it's a much more complex data type than the scalar types we'd been discussing before. Objects then are kind of along that same line. They are again another one of JavaScript's complex data types, and as a result are going to be a lot more interesting than the scalar types were. What is an actual object in JavaScript? Well, basically, an object is a thing in JavaScript in which we can have multiple values and even functions all stored together. In object language, a lot of times we refer to objects as having attributes and behaviors. The attributes of an object are basically the things about that object that describe it. So sort of like an object in the real world, basketball for example. A basketball has attributes. It's orange, it's round, it bounces, things like that. And again, just like objects in the real world objects have behaviors, things that they can do. The same two things are going to be true for the objects that we put together in JavaScript. There are going to be attributes that describe them and behaviors that they can perform. The actual attributes of objects are basically going to come down to just being variables, and the behaviors of objects are more or less just functions. The real advantage of objects in any kind of programming, JavaScript being no exception, is that objects make dealing with large numbers of variables, large number of values, much more manageable proposition than it would be otherwise. Objects are also extremely important in JavaScript because they are used heavily by the browser. Pretty much everything in the browser, everything on a web page, everything that eventually we're going to want JavaScript to be able to interact with is going to be represented in JavaScript as objects. So objects are something that you really have to understand, really have to be able to work with to really be able to use JavaScript to any great effect. Kind of an example to give you an idea of why objects are kind of important. Imagine, for example, that we had a JavaScript script that was going to manage circles. Let's say it was going to animate circles. We were going to have multiple circles on a page, and for one reason or another, these circles needed to be kept track of. Each one of the circles itself could be considered an object, because each circle has attributes, has values that describe it. For example, we could say that a circle has a radius, it has a color, it has an XY coordinate, it has a fill style, how it's actually drawn. And if we were going to do this with sort of traditional variables, we might have something like what we see here, where we have variables called circle radius, circle color, circle X, circle Y, circle fill style. Each one of these different variables would then have its own value. Now, that seems probably kind of okay on the surface, but if you imagine that instead of having one circle we had 10, then this would become very, very complicated. We would have circle 1 radius and circle 2 radius all the way up to circle 10. So we would basically have 10 different versions of each one of these 5 variables that we would have to keep track of and manage. What objects will let us do is to make that whole dealing with all of those different variables much more simple, much simpler and more straightforward. More or less what happens with an object is that we'll be able to take all of those different values and we'll be able to pull them all together and kind of store them under one roof in a way. We would call this collection of all of these variables an object, essentially. So the object itself might have a name, like here we might just say that this is the object circle, and inside the object circle, the object called circle, which itself would basically be a variable, we would have other variables stored, radius, x, y, color, fill style, each one of those variables with its own value. So really, from one perspective, an object is sort of a variable with other variables inside of it. So here we would have a variable called circle, and the variable called circle would have inside it variables with all of the other names, and each one of those variables could then have values. The values of the variables inside the object could even be other objects, objects inside objects, possibly. If we were to then extend this a little bit and think about it in terms of, again, having multiple circles on a page, if we take this object and give it a more specific name, circle 01 for example, then if we had three objects, three circles, it wouldn't be nearly as daunting a task to have to keep track of all their different values. We would have the radius, x, y, color, and fill style for circle 01. All of those values would be stored inside the variable circle 01, and then we'd also have circle 02 and circle 03, for example, each one with its own attributes, with its own variables stored inside of it. So at the top level of our program, all we would really have to deal with is three variables, circle 01, 02, and 03. We wouldn't have to worry all the time about all of those other variables that are actually inside each of our three objects here. Now, having the variables inside the object is certainly a good way to manage them, but it won't do us a whole lot of good if we're not able to actually access and work with the values of those sort of embedded variables. So here again, let's just say we're talking about a single circle object that has the radius, x, y, color, and fill style variables inside of it. The way we would actually go on then and be able to access the different attributes inside it would be by using what is called the dot operator. The dot operator is actually just the period, and what the period lets us do is refer to something that is more or less inside something else. So we could say something, for example, like circle dot radius, which would mean that we are accessing the radius variable that's inside the circle object, which of course would give us the access to the value 4.56 in this example. So if I were to do, for example, document.writeline circle.radius, what would actually print out would be 4.56. If I wanted to access the color, I would say circle.color, meaning the color variable that's inside the object called circle, which would give me access to the variable that has the value blue. So again, in a document.writeline, that would print out blue. I can also use the dot operator in a statement or in an expression when I'm actually assigning a value. If I said circle.radius equals 5.6, then what I would actually be doing is assigning the value 5.6 to the radius variable that's stored inside the circle object. So where do we actually get objects? One of the ways that we can actually create an object ourselves is by defining it ourselves. There's a classification of objects called user-defined objects, which are basically just objects that for one reason or another we decide are necessary and that we actually create. JavaScript also has many built-in objects, a really huge number of them, and all of the built-in objects taken together are usually referred to as the browser object model, or the BOM. The BOM, the browser object model, is a huge hierarchy of objects inside objects inside objects that basically represent every part of the web browser itself and every part of the web page that the web browser has currently rendered. So later in the course we will spend a considerable amount of time talking about the browser object model and the document object model, which is embedded inside of it. But that's a big subject, so that's something we'll save and talk about by itself a little bit later. For now, let's just concentrate on user-defined objects, since they give us a quick, easy way to start playing with objects and seeing what we can do with them. When we want to create a user-defined object, there's a couple of different ways that we can do it. The first way is through what's called a constructor function. A constructor function, as you can guess from the name, is a special type of function that actually lets us make new objects, construct new objects. Constructor functions tend to be valuable when we want to create objects that are going to be changeable, more or less, you might say. Constructor functions will act more or less like a template from which many objects of the same type can be created. In a different sort of situation, one where we already have kind of an object in mind, we probably don't need very many of them, we just want to store a particular set of values as an object. In that case, we can actually use object literals, which we'll also take a look at here in a minute. But for right now, let's go ahead and start off by taking a look just at constructor functions.
Let's start off by taking a look at a very simple constructor function. Let's say that in this example what we want to do is we, for whatever reason, have the need to have JavaScript keep track of some information about books. Just to keep things simple, let's say that books consist of just a title and a price. Those are the only two attributes that we're going to be concerned with. Of course, realistically, books have publishers and authors and lots of other pieces of information that go along with them, but since this is our first example of working with objects, we'll keep it simple and say titles and price are the only two things we're really worried about. So what I'm going to do is sort of like anytime I write any other function, I'm going to start by putting a set of script tags up in the head section of my document. And here inside these script tags, what I want to do is I want to write a constructor function that will let me store information about books as objects. So I'm going to start off with a keyword function. I'm going to follow that then with the name of the object, the name of the function that I'm making up here in essence. You'll notice that at this point it really looks pretty much exactly like any other function would. The only tiny little exception to that is the fact that I have capitalized the name of my function, which is something I would not in any other situation typically do. Capitalizing the name of a constructor function, a function that will be used to create objects, isn't a requirement. JavaScript doesn't insist that we do this, but it is something that's kind of done by convention to just make it easy for when you're looking at the names of different functions to be able to tell which ones are just regular functions and which ones are specifically functions for creating objects, or constructor functions in other words. So anyway, this is the beginning of my function. At this point everything should be very normal, hopefully pretty familiar to you from the discussions we've had previously about functions. What I need to do here inside this function though is that I need to use the keyword this, which is a keyword that we have not used previously, but it's this keyword specifically when used inside a function that makes it a constructor function, basically that tells JavaScript that this function is actually going to be used for the creation of objects. Whenever we use the word this, basically what it is a way for an object to sort of refer to itself. So what I'm actually going to put here for starters is I'm going to put in something like this dot title equals default title. Right? So more or less it looks a little bit like I'm just creating a variable, kind of like we have before. I've left off the keyword var. It's not needed in this particular case. The name of the variable I'm creating is title, and I'm assigning to it the value of default title, the string literal default title. The thing, of course, about this statement that's different than what we've done before is that instead of just having the name of the variable title, I instead have this dot title. What that actually tells JavaScript is that the title variable is not a regular variable, just sort of floating around with its normal scope and lifetime. Instead, we're saying that the title variable is specifically a part of this book, so that whenever this function is called, the new book that's created will have inside it this particular title. If we want to do the same thing for the price, I'll say this.price and we'll set a default price of 0.0, let's just say for example. And again, same sort of thing. I'm creating a variable here called price. I'm assigning it a default value of 0.0, and the price variable is not a normal variable. It is instead going to be an attribute of a book that's created through the calling of this function. So I have this.price saying that the price belongs to this particular book. And that's really it. That should be a working constructor function right there. So let's try it out. I'm going to come back down to the body section of my document and throw in a new set of script tags. Here inside these script tags, what I'm going to do is I'm going to create a variable. I'm going to call it B1. B1 for book 1, basically. This variable is where I'm actually going to store the new object that I'm calling. Now, typically, if I were to call a function, I would simply put in the function's name, sort of like so. But in this particular case, since this is a constructor function, JavaScript needs one more little clue to tell it what to do with it, and that is the keyword new. So again, another keyword. The new keyword tells JavaScript to call the book function as a constructor function and to create an object from it. Now, of course, when we say new book, JavaScript then comes up and calls our book function. When the book function executes into the new book object, it puts in a title with that value and a price with the other value. So we then end up with a new book being created. It's actually a process that's usually called instantiation, which basically just means creating an instance of. So here we're creating an instance of a book. And the new book that's being created will be assigned to the variable b1, where we should then be able to work with it. So let's see if we can actually do anything with it. I'm going to put in a document.writeLine, and I'm going to put in b1.title, followed by a break, since I'll probably print out some other things here in a minute. And let's see what we get for output. I'm going to switch back over to my browser. When I hit refresh, there it is, default title. So of course what happened here was the new book was created, the new book object I should say was created and stored in the variable b1. So when I said b1.title, that meant give me the value of the title that's stored inside the variable or inside the object in the variable called b1. We could of course do the exact same thing with the price. Document.writeLine b1.price followed by a break. There we go. Take a look at that in the browser, and there is my default price of 0. I could at this point also maybe, we could look at assigning different values to those variables. If I wanted to set an actual title for the book, I could do b1.title equals, and I could put in the actual name of a book here. Let's put in Still Life with Woodpecker. There we go. So here I'm taking the string literal Still Life with Woodpecker, and I'm assigning it to the title that's stored inside the book that's in the variable b1. Of course, the next thing that then happens is down here I'm printing out that title. So if we go back over to the browser and look, sure enough, there we are. We have put a new title into that particular book. We could of course do the same thing with the price, but at some point this starts getting a little bit redundant, I guess. Let's create another book. Let's do var b2 equals new book. There we go. That will create a second book for us. For this particular book, I'm going to do b2.title equals, let's do Half Asleep in Frog Pajamas. If you've never heard any of these books, by the way, they're wonderful. They're by an author named Tom Robbins. So yeah, certainly read them if you enjoy reading. Now that I've set a title for my second book, maybe just for the fun of it, I'll go ahead and also put in a price. So let's say that Half Asleep in Frog Pajamas goes for $15. Okay. And then if we wanted to, we could take a look and see that those values are actually there. Document.writeLine b2.title followed by a break. There we go. If I go back over and take a look at this in my browser, there's Half Asleep in Frog Pajamas. You'll notice that Still Life with Woodpecker and Still Life with Woodpecker's price, B1's price, is still there. We also now have B2, which is Half Asleep in Frog Pajamas. The important thing to maybe notice about that is the fact that each object has its own set of variables. Even though both of those two objects were both created from the same constructor function, when each of them were actually instantiated, when we actually used the keyword new, those two books became their own sort of separate entities at that point. And even though they were created from the same function, kind of rolled off the same assembly line, if you want to think about it that way, once they are actually created, each of them can be distinct in the actual values that they store. So we set a specific title for B1, we also set a specific title for B2. Right? Whatever the title is of B2 doesn't at all affect the title of B1. B1 and B2 both have their own copy of a title variable, their own individual, unique title variable. Okay, now that we've done one simple constructor function, let's go ahead and do another fairly simple little constructor function. This time what I wanted to do was create a constructor function to store information about squares. Say for example, we needed to display squares on the web page for whatever reason. I know, a lot of these examples are fairly silly, but we got to start somewhere. One way or another, when we store information about squares, we could store information about colors, all kinds of different things like that, but certainly the most important piece of information about a square would be the measurement of one of its sides. We only, of course, have to store the measurement of one side, since in a square all four of them would be the same. So let's start off maybe with just sides. What I wanted to do that's going to be a little bit different this time is I want to set this particular constructor function up so that instead of always starting a square off with a default side value, I instead want to set this constructor function up so that I can pass it the value of a side. So here, when I write my square constructor function, I'm going to set it up to receive one argument passed to the function, which I'm just going to call s, short for sides. Then inside the function, what I'm going to do is I'm going to say this.side equals s. So whatever value I actually pass to this function will then be assigned to the side attribute of the square that's actually being created. So we'll be able to sort of customize squares as they are being created. Down in the body now, I'm going to put in a set of script tags, and here inside this set of script tags, let's of course start off by creating a square. I'm going to make a square. I'm going to call it SQ01, let's say. And this is going to be a new square, so there I am calling its constructor function. And when I call its constructor function, I'm going to pass this square a side value of, let's say, 4. So again, kind of like in the last example, I'm using the new keyword to call the constructor function for a square, new square, and this time I'm passing it the value of 4. That particular expression then will end up calling my square constructor function, and we'll pass the value of 4 to that function, so the value of 4 will be stored in s. When the function actually executes, then a new square object will be created. The new square object will have a side attribute, a side variable inside of it, and what will be assigned to that side variable will be the value of s, which in this first case will be 4. So if I go ahead then, after I've created that object, and do a document.writeLine, and I print out sq01.side, there we go, followed by a break in case we do more of them. Right? If I go over and take a look at that in my browser, there it is, 4. 4 is stored there. Okay? There's lots of interesting things we could do with this. We could, of course, go on and add other attributes like color, for example. Maybe I'll modify my constructor function up here, so instead of just taking a side, it also takes a color. Maybe I'll just call the variable there, the argument that's being passed to the function c for color, and I'll say this.color equals c. Right? I could modify my function down here, so now instead of just passing 4, I'll also pass it a color. Let's pass it green. There we go. And if I were to take a look with a document.writeLine at what's actually stored inside there, sq01.color will give me access to that particular object's color variable. And let's see if it made it. Take a look at it in the browser. Sure enough, 4 and green. Those are the attributes of my SQ01 square. I suppose there's other fun little things that we could also do with this. In the case of squares, we could probably actually have it draw one for us if we want, although at this point it would be a fairly manual kind of thing to do. What I could do, for example, is I could put together a document.writeLine. There we go. And I could have it print out, maybe, I'm going to put single quotes here, a set of divs, which I should then be able to make appear as a square using a little bit of CSS. So with this div, maybe I'll set its style so that it has a background color. And for the background color, what I'm going to do here is I am going to append in the value of sq01.color, something like that. Right. Now I would also want to define a size for it, how big it should actually be, a width and a height. So I could go on with that right in here by doing a width and a height in CSS. And this statement's getting fairly long, as you can see. Where in CSS I would normally put in the value for the width, I'm instead going to open up my single quotes again, and I'm going to append in there sq01.side. And then the same thing over here where I would have put in the height in CSS. I'm going to break my quotes, come back out, sq01.side. Okay. So what I should end up with here, any CSS errors aside, I might have to go back and set some other properties here to get this to really work. But basically what I of course have is for a string literal, I start off the div tag, I have a style attribute, I set the background color, and then when it comes time to set the actual value for the CSS background color attribute, I actually append in from JavaScript the value of the color variable for my sq01 object. Then back into sort of string literal mode here, I have the semicolon that ends the background color property. I then have the width property, and for its value, I do sq01.side, right? And then I append to that again the string literal, the semicolon that ends the width property, and then I have the height property where I append in sq01 side again. I have then as a string literal the semicolon that closes off the height property. Okay. The quotes here actually go back and match the quotes that I opened up right here. Still both of them are considered to be string literals. They're just basically HTML and CSS code that JavaScript is outputting. The greater than sign right here is actually the close of the opening div tag, and then I have the closing div tag. So let's go over in the browser and see if that worked. I don't see anything at all. That's kind of funny. I wonder what might have gone wrong. Tell you what I'll do here in my browser is I'm going to come up to the view menu and I'm going to tell it that I want to view the source of this page. Well, that doesn't really tell me a whole lot. I just see my document.write line there as it should. Okay. In this particular browser there's also a debug mode, but oops, I still haven't turned that on, it doesn't look like. Let me come in and actually turn on that debug menu. There it is, the developer menu in the menu bar. Right? So I can now come up to develop, and this browser has a web inspector mode, which is nice because it doesn't just let me see the code that was downloaded by the browser, but it actually lets me kind of see how the browser interprets it. So I'm going to tell it I want to inspect this element, and why isn't it actually showing me anything down here? Well, there's the H1 element. It's just not showing me much of anything else. There's the body, there's the HTML. Let's try inspecting this one. I wonder if it's a little bit upset about how small my browser actually is right now. Well, strange. Maybe I'll have to go about this a slightly different way. Let's see, let me try up here in the head section actually throwing in some more traditional CSS. I'm going to put in a set of style tags, and I'm going to put in a selector for divs, basically saying that with every div what I want to do is I'm going to put in just a red border so I can see if the thing is actually showing up. Oh yeah, sure enough, it sure is. There it is. Yeah, this is kind of what I thought might happen. If I go ahead and let's say set its position to absolute, still not much of anything. It's almost acting like my width and my height aren't being interpreted for some reason. Kind of strange. Let's try it again up here. Oh, I think I know what I did. The size of our square is very, very small. I set it to just 4. Let's try changing the size to 400. That might make a bit of a difference. Actually, no, not much of anything. Okay. Well, let's go on then and see if I can set a width from up here. Width of 500. Oh, the units. See, sometimes it helps if I go back and I actually type things in regular old CSS. It helps me remember things that I might have forgotten when I was trying to do the JavaScript. Yeah, that looks like that might get us somewhere. Let me comment out those two CSS properties I put in, and then let me come back down to my JavaScript and actually put in my units, my pixels, which are going to be required. Going to need a pixel there. Going to need a pixel there. There we go. There's a 400 by 400 green square. That's lovely. Instead of 400, let's make it a little bit more manageable. 100. Excellent. Okay, so now that we've got that worked out, I should be able to come back here, of course, and change the properties of my square object and see them actually reflected in the drawn square. So maybe for the background color, I'll change it to red. Maybe for the size, I'll set it to 150 And sure enough, at that point, I get a 150 by 150 pixel red square, just like you would kind of expect. One of the things we'll talk about before too much longer is how to take something like this nasty document.writeline that I put together down here, and to actually sort of embed that within the object itself, so that once it's written once, it will never have to be written again, which obviously would be a good idea. I wouldn't want to have to go through this process any more times than was absolutely necessary.
Now that we have some kind of idea of what constructor functions look like and how to play with objects from that perspective, let's just look real quickly now at object literals. They're quite a bit simpler, I think, and let's just see how it's done.
Alright, object literals are another way that we can create objects, but they tend to work best in a slightly different sort of situation than what we were using our constructor functions for. I'd have to say overall constructor functions are probably best when you are wanting to create multiple objects of the same type. Whereas object literals, I think, tend to come in most handy when you just need sort of a quick throwaway object for whatever reason. Maybe you have multiple variables and you just want a convenient way to be able to handle them quickly and easily for a small part of a script. Taking them and combining those variables into an object literal can be pretty handy. So what I'm going to do here is I'm going to throw some script tags into the body section. I'm going to create a variable, and let's say that what we're going to do is we want to be able to store a person's first and last name together quickly and easily in an object literal. So I'm going to create a variable to hold this object. I'm going to call it P1 for person 1, and then what I'm actually going to assign to it then is an object literal. Now you remember previously we've talked about other types of literals. We've had things like string literals. This is a string literal, things like that, where it's actually the quotes that tells JavaScript, hey, this is a string literal. We've had things like numeric literals, where we just assign a number to a variable. Well, anytime we're going to create a object literal, the special magic symbols that tell JavaScript that that's what we're doing is curly braces. Whenever JavaScript sees the proper notation used inside curly braces, it understands automatically that what we're wanting to do is to create an object literal. So what we actually put inside these curly braces is sort of similar to what we had done before when we were doing our constructor functions. We still need to basically name our attributes and give values to them. So here, since this is a person, let's say that I want to store a first name and a last name. The way I would actually do this in the object literal notation is I would say something like first name colon, and then I would put in the person's actual first name. I'll put in Victrola. Okay? So what I'm actually doing there is I'm saying in the new object that's being created, create an attribute called first name and give it the value of Victrola. If I wanted to create a second attribute inside this object, I would separate it from the first attribute with a comma. So let's put in a last name attribute, and let's set this to firecracker. Something like that. So that would be an object literal. This would result in an object being created that had in it a first name and a last name attribute that had those two values assigned to it. So once that's done, I have an object that's really no different than an object that was created using a constructor function. I can still work with it the exact same way. If I say p1.firstName, for example, then I'll be accessing the value of the first name variable that's stored inside the object p1. So the first name variable that's stored inside the object p1 should give me the value of Victrola. So let's take a look at it in the browser. There it is, Victrola. If I wanted to access the value of last name, then I would, of course, do p1.lastName. So it's really just sort of a different notation, a different way of going about creating an object. As you can imagine, doing it this way, you don't benefit from sort of the reuse of the constructor function. If I wanted to create 10 people here, for every one of those people, I would have to specify that they have a first name and a last name attribute. Whereas if I had used a constructor function, it would already know that it had first name and last name attributes. I would simply have to provide some value for them. But in situations where you don't need to have many copies of objects floating around, sometimes this notation is much shorter, more concise, a little bit easier to read maybe, once you get used to it anyway, and can come in quite handy. Certainly one of the places that I like to use it best is whenever I have a function that I need to pass a lot of different attributes to, and I'll show you that here next. So object literals can also be used as a convenient way to pass multiple values to a function. So let's say, for example, that I had a function that I had written. I'll put it inside some script tags here in the head section. And let's say that this function is supposed to output the attributes of a circle, sort of like we talked about in the beginning of this segment. So inside this function, which I'm going to call print circle, right, what I'm going to want it to do is I'm going to want the function to be passed all of the important attributes of a circle. Let's say, for example, it's going to be passed the circle's x-coordinate, its y-coordinate, its radius, its color, and its fill style. Something like that. And then inside the function itself, it's going to print out all of these different values. So let me throw some document.writelines here together. Let's print out x colon followed by the value of x, right, followed by a break, and then I'm going to copy that to do all my others. That'll be the one for y, radius, color, and fill style. Let me just go back and change the variable names appropriately. Y and y, radius and radius, color and color, and fill style and fill style, something along those lines. Alright, so I could of course use that function here. Let me move up on the screen here a little bit. Down here in the body, I'm going to put in another set of script tags. Let's say that I want to print a circle, calling my function here. And let's say the circle's values are 3 for x, 4 for y, 56 for radius, its color is yellow, and its fill style is none. Right? If I take that and pull that up in my browser, you can see it works just fine. Right? Now, using object literals would basically just kind of change the way that I put all of this together. What I could more or less do here, and you might find this more simple or more complex one way or another, but it certainly can come in handy one way or the other, is let's say that using object literals, instead of passing all of these values separately, what I wanted to do is I wanted to pass them all just as an object. So what I could do is I could change this over to object notation. Okay? So I put curly braces around all the values. I'm going to say that that's x, that's y, that's the radius, this is the color, and over here we have the fill style, something along those lines. So now all of those values are being passed instead of separate values as just one object literal instead. Up here in my function then, instead of having all of these separate variables to receive all the values that are being passed, I could instead say that they're just passed a variable called specs, the specifications for the circle. So then to access the values, I would just say specs.x, specs.y, specs.radius, specs.color, specs.fillStyle. If I come back over to my browser and take a look, you see it works exactly the same way. It's just sort of a different style. So just running through to make sure we understand what's actually happening here. I call the print circle function, and when I call it, I pass it a single object created with an object literal notation. So the object that's passed has x, y, radius, color, and fill style as its variables, as the actual attributes that are stored inside it. When all of those are passed up here to the function, they are stored in an object called specs. So then in all of the document.writeline statements, I just pull out each of the individual values, specs x, specs y, and so forth, and I'm able to access them all that way. This might seem kind of strange in this particular situation because I think it probably on the whole actually meant I had to do more typing in order to use this particular way of passing those values. But there would be certain situations where there would be other advantages to passing things as objects instead of passing them as individual values. For example, if I had a function that maybe did or maybe didn't need to be passed a particular value. Say, for example, the fill style value was optional. You could specify it or not when you call the print circle function. Well, by having it stored there in the object literal, I could either put in the fill style value when I pass them, or I could not, either way. Whereas if it was a regular function, it would be much more picky about making sure that I actually did pass a value for a particular variable that was present there. As a matter of fact, with this particular way of doing it, I could pretty much pass an empty object, and then when it came time to actually print out the values, I could check to see if each of these values were actually there before I tried to print them, and if they weren't, I could just fill in some default value, for example.